Alright, we are recording. This is the first real video that we're doing here. So, how's it going, everyone? Welcome back to the channel. And today we are going over the most simple introductory circuit that you're taught when you're learning electrical engineering and circuits specifically. So, we're going over a basic LED resistor circuit. I'm going to show you guys the schematic that I have. I'm going to show you guys how to test the simulation. I'm going to show you how to hand calculate current going through that circuit, and I'm actually going to build a circuit so you guys see it working. So this is a very simple circuit. I'm assuming that you have a very basic level of electrical engineering, specifically Ohm's law, for this video. I will be using a microcontroller, but that's just for a power supply. I'll actually make a microcontroller video in the future. So when you see the little Arduino Nano, don't get too alarmed that you don't know what's going on with it. Just bear with me, you'll see. Alright, let's get right into the actual circuit. Alright guys, so like I said, this is our simple little LED circuit. We are using a 220 ohm resistor right here. As you can tell by the color bands, we have red, red, brown. That means 220 ohms with a gold tolerance, but we're not too concerned with the tolerance at this moment. So that's hooked up to our LED, which is right here, light emitting diode. And the way you can tell what's positive and negative on the LED, typically the longer leg of the LED is positive. So actually we have it flipped. So why don't we go ahead and flip this. Let's see, rotate. I want to flip. There we go. And we're going to go ahead and line those leads up. So that's another thing I wanted to mention. I want to mess up in these videos so that you see me messing up and see how I fix my problems. So that right there is one of the simplest and most common errors when you're making circuits. When you have a polarized component and the circuit's not working, I'd say a solid 7 out of 10 times it's just one of those components is flipped in the opposite direction. So the longer leg right here is our positive lead. Now, if you have an LED where both legs are at the same length, you can also tell by looking at the top of the LED, there's going to be a side that's actually flat. See how this side's kind of rounded and this side's flat? That flat side denotes that it's the negative lead on that side. So, this is our microcontroller right over here, our Arduino Nano. Now, you can have any sort of power supply for this circuit. I'm choosing to use a Arduino Nano because when I actually build the physical circuit, I'm just going to be using my Arduino Nano as my power supply, so I wanted to show you guys exactly what we're going to be dealing with. Alright, so as you can see from right here, it's kind of hard to tell, we have our 5 volts going into our power bus line. This is this bottom line on the breadboard right here. These are all connected. So from here, we're jumping over, pulling down our power through our resistor. From our resistor, we're going into our positive lead. That's going to run through the diode, come back down, and ground itself off, completing the circuit back to our ground point right here. So that is our basic schematic. Now I'm going to pull up a notepad so that you guys can see me calculating the current going through this circuit using Ohm's law. Alright guys, so here we have our little simulation going. So just so you see it, this is our 5 volt power source right here. This is our 220 ohm LED, 220 ohm resistor, sorry. This is our multimeter that we have set to amps that is connected in series with the circuit. This is our ground point right over here. So before we open the simulation, I want to go ahead and give you guys 5 seconds to pause the video in case you do want to attempt to calculate the current going through our circuit by yourselves. So I'll give you a 5 count. 1, 2, 3, 4, 5. 22.727 milliamps is our final answer. Now, how did we get that? Let's go ahead, pull up a notepad. I will show you exactly how we did it. got some code there. Let's see. So, as we know, Ohm's law is V equals current times resistance. So we want to solve for our current, right? That's our I. So as of right now, our I is unknown. We know it's something. We don't know what it is, so we'll put question marks. However, we do know our voltage, right? So we have our V equals 5. Let's capitalize that. V equals 5 volts. Don't forget our units. And we also know that our resistance throughout the circuit is 220 ohms. So, using our basic algebra skills, we're going to go ahead and rearrange that original equation. So instead of V equals IR, we're going to have V divided by R equals I. Now plugging in for that, we're going to have our 5 volts divided by our 220 ohms. That's going to give us our I. So plugging that into the calculator, you get something along the lines of 0.0027. You get 0.0222727. That's what my calculator is showing me. Now that's how many amps we get. All right, that's how many amps. So this ends up being 0.0227227 amps. Note that with our A, right? Volts divided by ohms equals amps equals our I. However, we electrical engineers don't like to work in, it's almost like a convention where you don't necessarily want to work with something with nothing in the unit place for the decimals. You understand what I'm saying? So we have a 0 in our unit place. We want to convert that into milli or pico or micro, whatever gives us the most almost physically understandable value. So what a lot of people would go ahead and do is convert this into milliamps. How do we convert that into milliamps? We're going to go ahead and we're going to move that decimal place over by 3, right? So I'll show it to you guys. So we have 1, 2, 3, well 4. Move it over 4 times. So from here we have 1, 2, 3. Oh no, I was right, 3. Yeah, 3. Sorry, because it's times 100 or divided by 100. So 1, 2, 1. No, 1, 2, 3. Okay, sorry, I messed myself up there. Like I said, I want you guys to see me messing up. So I'm probably not going to cut that part out. I want you guys to see me messing up because a lot of these videos don't show that. All these videos on YouTube don't show people messing up, and it almost makes you want to beat yourself up when you have to do like a simple little error like that. Literally, I just couldn't. I misclicked my arrow button, so I couldn't calculate how many times I was jumping my decimals. So 1, 2, 3. So that's 22. Moving our decimal place over 3 times, we have 22.727 milliamps. That's also something you should also pay attention to. So see how here I have amps with a capital A, but this M isn't capitalized. You don't capitalize the multiplier almost. So the multiplier of the unit, you don't capitalize that. You only capitalize the unit itself. So these are milliamps. Together it's 1 unit. However, milli is just the multiplier of the amps. So the M stays small, the A goes big. Equals I. Something just fell. I wonder what fell. Sorry about that, if you heard that. But yeah, 22.727 milliamps. That's how we calculate that. So now, next up on the docket, I guess I will build this circuit physically and try to show it to you guys the best I can. Alright guys, so sorry for the drop in quality. I have to film this part on my phone because my face cam doesn't really pick this up all too well, but I want you guys to see in detail. So, also excuse that pen. That pen is just blocking the light coming off the microcontroller because it kind of blinds the screen. But anyway, as you can see, we have right here, we have our 5-volt pin, our resistor connected to that 5-volt pin through the breadboard. Those 3 dots, they're all connected. We have that power jumping over, going into the positive end of the LED. And then behind that, if you guys can see right there, is where we're going to ground it. Now I don't have it hooked up just because I wanted you guys to see it happen live and in person. So let's go ahead and complete the circuit by grounding it off right there. See that? Now we are lit up. That is our circuit. That is the final product. I'll go ahead and take that off just so it doesn't blind you guys. But yeah, that is our circuit. Pretty simple. We love to see it. And yeah, let's switch back to Facecam to recap what we went over. Alrighty guys, so what did we learn today? We learned how to calculate the current going through our circuit to supply our LED in this case. We got our 27 or 22.27 milliamps. I showed you guys how to set up a simple circuit, how to read the positive and negative leads on the LED, and overall, very simple, very introductory. I just want to kind of get you guys to see the structure of these videos. Obviously, this is my first video. Still trying to figure out what's the best way to disseminate this information to you guys. But I hope you guys can actually see how I did what I did. I hope you appreciate the mistakes I made and how I fixed them. I feel like that's an excellent way to learn. Overall, I do encourage you guys to go out there and try it yourself. A lot of these components are relatively cheap. I'll put some links in the description if you guys want, or I'll respond to your comments if you guys actually request these components that I used. Yeah, I hope you guys got something out of this. You know, this is really as much as that it's to teach you guys how to do some of this stuff. It's also to teach better solidify my understanding of these elementary electrical engineering concepts. So for the next video, we're going to start to ramp things up because I'm going to assume that you guys have some electrical engineering knowledge. I will link you guys some excellent text and maybe even some other YouTube videos to further your understanding of circuit analysis and electronics. But yeah, next time, more than likely, we're going to do a microcontroller project. Maybe give you guys a little software, tutorial on how to use the simulation software that I use. It's called a Multisim. So definitely have a lot of stuff that I can teach you guys. Definitely have a lot of stuff I can make content on. Feel free to shout out in the comments what you want to see, what recommendations you guys have in terms of how I get this knowledge out to you. I'm thinking next time do more of a slideshow format for the theory part instead of just showing you guys just the schematic and talking to it, and hopefully getting some sort of canvas that I can actually write on and show you guys how I do my calculations that way instead of the notepad. But yeah, I wanted this to be more of like a experimental type video where I teach you guys how to do stuff and also kind of find my footing in terms of making YouTube videos, because electrical engineers are notorious for having poor communication skills, and that's something I am trying to work on, right? So, yeah, I hope you guys enjoyed the video. Take care.